Alright, welcome to section 2.4, linear inequalities in two variables. So some of the steps for graphing linear inequalities. Well, the first step you want to do is to find the boundary. Okay, so graphing linear inequalities is different than graphing just a line. With a line, you just draw that one straight little simple line for graphing. But with an inequality, what happens is you're determining which side of the line our answer is going to be on. So first you would need to find the boundary, just like you would normally when graphing a line. And then the next thing you're going to do is you're going to find a test point. You'll pick a test point from either side and determine if it works with the rule or the equation that you have, the inequality that you have. And from there, you'll determine which side to shade. So the last thing you'll do is you'll shade the right side. Shade the correct side. Okay, let's go ahead and take a look at some of this. Example 1. Graph the following linear inequalities. Be sure to state the boundary line and the test point used. Okay, so make sure to note that. That is something that I will always be looking for, especially on exams. Okay, so state the boundary line. Well, first thing we're going to do for a boundary line is, real quick, let's notice, this is not an equation, it's an inequality. We have that inequality symbol. So we need to know if this is going to be a solid line or a dotted line. Well, if you recall, since this is not the equal to inequality, that means we're going to have what is called a dotted boundary line. Okay, and that is something I'll look for in your work. Please note dotted boundary. Okay, so the next thing we need to do is to determine what the actual boundary line looks like. So we're going to go ahead and graph the boundary line. So I'll go ahead and say for boundary line, since we're looking at the boundary line, we're going to change the inequality symbol to an equal sign. And that'll give us an idea on why it's a boundary. So note that's why I called it my boundary line, because this is not my actual equation. So let's go ahead and solve for y to see if we can graph this line. Oh, what do you know? This is that special type of equation where we only have the y. So this means that we're looking at the equation of a line that's horizontal at y equals 1. Okay, so that's my boundary at y equals 1. But recall, we have a dotted boundary. So at 1, we're going to go ahead and draw in our dotted boundary line. Now, it would be solid if we had had an equal to inequality, but we don't. And remember our arrowheads, and there we go. So that was the first step. Second step is to pick a test point. So basically what you do is you just pick a test point on either side of your boundary line. I'll go ahead and use 0, 0 because it's easier. So go ahead and label test point 0, 0, TP for test point, and then let's do the testing. What do we do when we're testing? We're going to plug it into the equation we have originally, so y plus 3 greater than 4. And we're going to see if this statement is true using this test point. So we're not solving anything, we're just plugging in the values and seeing if it's true. So x and y are both supposed to be 0 in this. So go ahead, y is 0, plus 3 greater than 4. There's no x value, but that's okay. So then I have that 3 must be greater than 4. Is this true or false? The answer is 3 is not greater than 4, so this is not true. It is a false statement. So since that is false, what this means is any other point on this side of my boundary line will also be false, which means all of my answers should be on the opposite side. So all of these points up here will work, and I'll go ahead and shade it in. So please note, when you shade your work, please go ahead and shade all the way up to the top of the graph. Now this works here for shading. Sometimes people like to do little crosshatch for shading, but it should just extend all the way to the end of your graph. Okay, and let me go ahead and erase this because that's not part of our solution. And there we go. For our inequality, we have found all the points that work for my inequality are in the red zone area. Okay, so let's go ahead and take a look at another example. So we have 4x plus 2y is greater than or equal 6. And we're told to graph this. So I know this is an inequality. How do I know that? Well, we have the inequality right there. So first things first, what kind of a boundary do I have? Since I have that equal to mark underneath right there, I know this is going to be a solid boundary. And always make sure to write that. So now let's go ahead and take a look at the boundary line. And when we're working with the boundary line, we get rid of the inequality just so we can graph it. Okay, let's go ahead and solve for y as usual to get into slope-intercept form. So solving for y, we'll have, so subtracting the 4x from both sides. We want to get y by itself. Let's go ahead, divide everything by 2. Why did we want y by itself? Well, when we do that, we get our equation into slope-intercept form. And then we can find our slope, which is -2, and our intercept, which is 3. So m is equal to -2, and my y-intercept is 0, 3. Okay, so that's my boundary line. Let's go ahead and graph my line. So my y-intercept is at 0, 3. Always graph the y-intercept first. Doop, boop. And then my slope, I'm going to use my slope to find 2 other points. My slope is -2, which means it's 2 over 1. So I'm going to go down 2, right 1. And I start from my point, so I'll go down 2, boop, boop, right 1, doop, right there. And that is at 1, 1. Now, let's do it again. Down 2, right 1, and that is at 2, -1. And the next question is, was this a solid or dotted? This is solid, because we had that equal to for the inequality. So let's go ahead and draw in. And there we go. So next we're going to do, let's see, we've done our boundary line. Ooh, now we need our test point. As usual, I like to pick 0, 0 if possible for my test point. I'll go ahead and label it there, and then I'll write testing up here. Always make sure to label your work. So we're testing 0, 0, and we're testing it with our original equation up there. It's 2x. Oops, sorry, it's 4x. 4x plus 2y greater than or equal to 6. We'll go ahead and plug in 0. Remember, we're not moving anything around. We're just testing the sides to see if they are equal. So that's my x and y value. So 4 times 0 is 0, plus 2 times 0 is 0. Is that greater than or equal to 6? Is 0 greater than or equal to 6? I'll go ahead and put my question mark. The answer is no. This is a false statement. 0 is not greater than or equal to 6. Go ahead and box my answer. That's false. So that means all the values on this side are not going to be true, which means the values on the other side will be true. So let's just test that out to see if that actually is true. Let's pick a value from the blue shaded side and see if it makes sense with my inequality. So what's a point in the blue shaded side that would work? How about 5, 5? Let's plug that in and see if that works. We're just going to do this for fun as scratch work. So let's check 5, 5. This is scratch work. I'll call it scratch work. Okay. So we're going to have 4x plus 2y. I want to see if that's greater than or equal to 6. So 4 times 5 plus 2 times 5. Is that greater than or equal to 6? Well, 4 times 5 is 20, plus 2 times 5 is 10. And we have 30 is greater than or equal to 6, which is true. So yeah, it does make sense. The values that are in the blue shaded zone make this inequality a true statement. Values from the other side make it a false statement. And you can go ahead and play around with some other points. Pick some random points and then check them out and see if they make sense to you. Okay, let's see. Example 2. Graph the following intersection of 2 linear inequalities. Okay, so now we're moving this up. Instead of just graphing one inequality on a graph, we're going to take a look at 2. Now, what do these two say? This says x plus y less than 3 and y less than or equal to 2. Okay, so this is going to be an and statement, which if you recall an and statement, we're talking about the intersection of those two. So we'll have to keep that in mind after we graph them. So easiest things to do first is to graph each one and then highlight the area that they intersect. So let's go ahead and take a look at each of these separately. I'll go ahead and graph the y less than or equal to 2 first, because that's the simpler one. My boundary is a solid boundary. How did I know that? Because we have that equal to symbol underneath my inequality. And then what is my boundary line? My boundary line is just y equals 2. Once again, all we do is we replace the inequality with an equal sign. So we have y equals 2. I'll go ahead and graph this in green. That's the horizontal line right here, y equals 2. And then we have to use a test point. So as usual, I always pick 0, 0. Unless my graph goes through 0, 0. Then I have to pick another point. So testing. So is 0 less than or equal to 2? Ah, look at this. This is the true statement. The answer to this is true. 0 is less than or equal to 2. So since 0 is less than or equal to 2, we'll go ahead and shade the side. That was true, which this time is actually where our 0, 0 comes from. Okay, so let's go ahead and shade this in. And sorry if my voice sounds a little weird. I'm getting over a small cold or something. Alright. Next, so that was one. Let's graph the other one. So this one's a little more complicated because it has x and y in it. But let's take a look. What would our boundary be? Our boundary is going to be dotted. So dotted boundary. And why would it be dotted? Because there's no line underneath the inequality symbol. So let's go ahead and take a look at our boundary line. Now when we do our boundary line, once again, we just replace the inequality with an equal sign. And let's solve for y. So we subtracted x from both sides. I'll go ahead and show that real quick. So you notice I'm starting to skip a few steps because I'm assuming at this point you've practiced this out enough. But once again, if you ever have any questions on any of the videos, please come by my office hour. Okay, so my slope is going to be the value by x, which is that -1 that's sort of hidden. And then the 3 is my intercept. Okay, so let's go ahead and graph that. I will graph that in blue. So y-intercept is at 0, 3. Yep. And my slope is -1. So -1 for a slope is going to be down 1, right 1, or we can change the negative to the value on the bottom, which would be up 1, back 1. I'll go ahead and choose that option to find two different points. So I'll do the up 1, right 1 for 1 point, which will be -1, 4. And the other point, down 1, right 1, right here, which will be 1, 2. Let's go ahead and graph this line in straight as we can make it. Okay, now we need to do a test point. As usual, I'm going to pick 0, 0 since my line doesn't pass through it. So let me erase my mini scratch work here for the slope. Let's go ahead and show the work for the testing. Always list which point you're testing, by the way. Okay, so we're doing 0 plus 0. Is that less than 3? Once again, I plugged in x and y, or 0 and 0 for x and y. So then I have 0 is less than 3. Is that true? The answer is yes, this is true. 0 is less than 3. Circle that. So since that is true, we'll shade the side that our test point came from, which is this side right here. Now you might be tempted to say, aha, we are done. We are not done. How come we're not done yet? Recall, we were looking at two inequalities, and we wanted to figure out the AND statement for those two inequalities. Okay? If it was an OR statement, we would have to look at it differently. But we're looking at an AND statement, which means intersection. So, the intersection means where they only agree, which means that this area here is where these two graphs agree. It's where the blue and the green intersect. So that is the AND statement for my inequality. I'll go ahead and highlight in a different color where they intersect. And that would be the answer to my problem. So the question is, if this was an OR statement, what would I shade? Well, if this is an or statement, I would also include this area here and this area here in my shading. That would be if it's an or statement. But since it's not, we only include where the two agree. Let me just clean up my edges here. But alright, so that is it for this section. If you have any questions, feel free to drop by an office hour or send me an email.